Today, I'll be presenting my project titled Post-Infrastructure Rerouting Urban Water Systems for Sheikh Wuhui Sewage Treatment Works. Firstly, through watershed and heterogeneous planning, this project proposes the transformation of the site into a high-density mixed-use community that aligns with natural boundaries. With the estimated current population to be 10,000 and the government master plan proposal increasing that number to 14,000, this proposal aims to accommodate for a projected population density of 16,000 people per km squared, balancing urban expansion with environmental restoration. Each watershed boundary will have a 40% residential land use allocation, and my design site is located within 2 watershed boundaries, holding an estimate of 3,000 people. Originally built in the 1980s, the Sheikh Wuhui Sewage Treatment Works has undergone multiple expansions, including a 2015 plan to upgrade it into the Sheikh Wuhui Effluent Polishing Plant, serving 300,000 residents in Sheung Shui, and Fanling. Alongside the government plans, the site has potential to be redeveloped. Today, the site is one of several zones that contributes to ecological fragmentation, disrupting habitat connectivity between surrounding green spaces and further restricting biodiversity movement. Most areas are currently covered with urban green, which suggests that more habitats should be introduced to improve fragmentation through my site. Additionally, the site's existing highly impermeable industrial infrastructure has no spatial correlation with and disrupts natural water flows, weakening the watershed's ability to regulate stormwater and support ecological processes. By studying the existing sewage works' key infrastructure and processes of the sewage water, there is an opportunity to create and retrofit both infrastructure and systems to feed the needs of my project. This project aims to develop new hydrological networks as the backbone for this high-density neighborhood development. Key strategies include strategically positioning blue and green spaces to promote sustainable stormwater management, water recycling, and habitat enhancement. Also, to repurpose existing infrastructure to fit current development demands, as well as to provide multifunctional open spaces for both human and nature. Finally, the design will accommodate the growth of nature and increasing population density over time through an incremental development plan. For my first strategy, the development of my project starts with the nature-first approach, aligning both the blue and green distribution and human flows to natural watershed boundaries. Next, alongside the strategic placement of blue and green, this then improves the permeability for water in low-lying areas on site. It also increases the type of habitats present, increasing overall ecological value of the site. Lastly, the current hydrological system of the sewage will be rerouted for stormwater, greywater, and black water to be circulated and reused within the new residential development. My next strategy of adaptive reuse presents the opportunity to retrofit several key existing infrastructure to provide functions for both human and nature. This example shows the treatment and reusing of both stormwater and greywater to allow the existing sedimentation tanks to be used for both recreational pools as well as aquaponics, encouraging local food production. By introducing community aquaponics, a new system that cleanses and reuses storm and greywater is circulated within the site. For black water systems, I looked into the Living Machine system in Sharon North that is ecologically capable of treating wastewater to high quality standards while providing multifunctional nature-integrated environments for the public. However, this system does require a greenhouse for more temperate climates. This presents an opportunity for the existing sludge digestion tanks to be converted into living machines, treating wastewater within my site. Alongside the consideration of residential units that I will be proposing, these various storm, grey and black water treatment systems on site can allow for an estimate of 80% of water on site to be reused annually. My final strategy develops the first two strategies in an incremental plan. By starting phase 1 with more landscape first changes, firstly aligning human flows with natural boundaries. The widening and naturalization of the Sheksheng River that cuts through my site will increase accessibility, permeability, and function for humans. The second and last phase then incorporates the human development aspect into the site, around the ecologically well-established site. New mixed-use residential models will also be implemented to improve and assist the connectivity of flora and fauna, not only around, but through infrastructure. Finally, my design will introduce 14 residential and 9 mixed-use developments, accommodating a population of estimate 3,200 people. To conclude, my design post-infrastructure reduces the reliance of external water supply to create a self-sustaining, high-density neighborhood that reroutes urban water systems within and aligns with nature boundaries. Thank you.